NATO's decisive move wasn't a torpedo. It was exposure. When the Russian Kilo-class Novorossiysk surfaced with a dangerous fuel leak and failing systems, Sweden treated the Baltic like a lab tank. Gripen fighters harvested electronic whispers with Arexus. Saab 340S recorded cavitation, pump vibrations, and engine stress. Visby corvettes added high-frequency pings and radar imaging. The result? A multi-domain dataset Russia can't erase. A permanent fingerprint of a quiet sub under duress. Keep watching to see exactly which signatures were captured and how this changes every future Kilo deployment. Before we move on, please take a moment to subscribe to the channel and like the video. Why did a sub breaking the surface sound louder than a parade? Because the Baltic isn't deep blue water. It's a shallow bowl crowded with shipping, ferries, wind farms, and undersea cables that double as tripwires. Sound bounces between the surface and the seabed. Signals that would fade in the Atlantic ricochet here. A surfacing hull throws a radar return, an exhaust plume, and a stack of mechanical noises into a space designed by geography and industry to reveal them. The Novorossiysk came up sick. Fuel leak, navigation problems, under tow. Staying down risked flooding or grounding in waters that averaged the depth of a city block. Surfacing felt safer, but visibility is currency in the Baltic, and NATO holds the bank. Sweden didn't rush in with lights and loudspeakers. It tightened a net. Gripen patrols drew boxes on the sky. Saab 340S held high orbits like patient metronomes. Visby corvettes slid along the edges at speed, their composites blending into clutter on hostile radars while their own sensors stayed sharp. Sea and air became lanes, and every lane had a watcher. Shallow water turns whispering machinery into a drumline. Cavitation starts earlier when a propeller or a pump is stressed, and those bubbles pop with a signature. Gearbox teeth hum in harmonics you can chart. Auxiliary generators cough in steady intervals when loads spike. In deeper oceans, much of that is swallowed or refracted away. In the Baltic, the surface and the bottom work like hard walls in a hallway, folding and stretching each tone until an operator can separate one source from another. Even the tug's screws added a reference beat to time everything else against. Above, wide-area radar from the AEW platform didn't care about the hull's paint. It clocked a shape, a speed, and a course, then refreshed it on every sweep. ESM did the quiet work, peeling apart emissions, tagging bearings, and triangulating the faintest blips into coordinates. Timestamps lined up across jets, turboprops, and corvettes. A single track formed, not just where the sub moved, but how it behaved through each power dip and restart. Gripens with Arexus became the ear that never blinked. They pulled metadata from brief, nervous communications attempts. They spotted interference patterns that shouldn't be there. Sidebands from a misbehaving converter, timing jitter from a stressed control loop, the skipped heartbeat of a safety relay. None of it required content. The structure alone told the story of equipment wrestling with bad inputs, fuel contamination, and power discipline on the edge. Sweden didn't learn this posture from manuals. It learned it the hard way in 1981, when a Soviet whiskey-class boat put steel on Swedish rocks. That incident seeded a doctrine: layer sensors, synchronize clocks, and let data interrogate intruders. The modern version swapped flares and binoculars for passive arrays, high-frequency pings, and airborne ESM. The goal stayed the same: know the intruder's condition before the intruder knows yours. By the hour's end, the surfaced sub existed in 3 stacked realities. Radar painted its outline in motion. Acoustics wrote its stress in blades, pumps, and gear sets. Electronic surveillance traced a heartbeat of power cycles and misfires. None of those layers needed a boarding party. They needed alignment, clean timing, and a calm perimeter. Now the tank is clean and the subject is contained, we can open the vault. The real prize wasn't the hull in daylight. It was the stream of secrets leaking from every struggling subsystem, captured live and filed for the next time a Kilo tries to slip through the same waters. What secrets can you lift without boarding a submarine? More than you think. especially when the boat is hurting and the clock is synced across every sensor in the sky and on the water. The goal wasn't a snapshot. It was a library. Electronics under stress, acoustic behavior at tow speeds, radar returns from a scarred hull, and thermal traces from systems trying to stay alive. Each layer fed the others. Each spike, dropout, and plume went into a timeline that turned chaos into a usable fingerprint. Malfunctions became breadcrumbs. Faulty pumps cycled out of rhythm and threw electrical noise onto the spectrum. Uneven propulsion under tow made the propeller blade rate wobble and brought cavitation earlier than it should. Emergency power handoffs clipped lights and converters, which showed up as timing jitter and brief carrier drifts. Comms windows opened and slammed shut, not to talk much, but to signal coordination and status. Those moments were gold because stress forces systems to reveal their margins. On the Gripens, Arexus hunted the quiet bursts meant to hide. Low probability of intercept links are designed to blend, but their behavior still leaves a trail. Demodulation characteristics tell you modulation choice and filter health. Timing jitter points to clocks fighting dirty power. Error patterns, especially repeated frame corrections, flag weak amplifiers or mismatched antennas. Even when content stays encrypted, the structure exposes the state of the radio room and the control electronics feeding it. The Saab 340S worked the acoustic side, logging the sub's mechanical life minute by minute. Under tow, the propeller's blade rate becomes a metronome, and any bend or nick introduces sidebands you can count. Cavitation onset at certain RPMs marks blade condition and water flow around the hull. Gearbox harmonics stack at predictable intervals, but misalignment shifts them off-center. Pump cycles tell you which systems are taking on load and when they shed it. Auxiliary generators, kicked in to stabilize power, hum at set frequencies that wander under stress. Put all of that on a timeline and you get a health chart of a boat that never invited you aboard. Closer in, Visby corvettes used controlled high-frequency pings with tight waveforms. Short, deliberate pulses mapped hull contours, sail edges, and appendage alignment. If a propeller blade was deformed or edges were rough, the returns showed asymmetry. The same ships ran passive arrays non-stop, banking hours of ambient noise for later analysis. The trick wasn't volume, it was consistency. Every new minute added context to the last one. Radar and infrared filled the gaps. The PS-05/A on the Gripens tightened the picture, giving an imaging sweep of the hull's condition and any odd angles caused by tow points. Skyward-class IR and EO sensors caught thermal plumes from exhaust and the heat bloom of emergency cooling circuits. A clean boat keeps its heat low and regular. A stressed one sloshes between hot and cold as systems bite and release. Here's the moment that tied it together. A short comms attempt from the tug stamped the ESM log. 2 seconds later, the acoustic track spiked with a pump surge and a generator frequency drifted out of band. Cross-correlate those marks and you can say, down to the second, when an electrical anomaly cascaded into a mechanical response. That correlation let analysts assign causes, not just observe effects. By the end, the electronic take wasn't just intercepted signals. It captured communications behavior under stress, interference fingerprints from dirty power, and subsystem health indicators hiding in timing and error trails. Arexus walked away with a template built to recognize future LPI and low probability of exploitation attempts from Kilo-class boats, even when their operators tweak settings. And once a template exists, you look for it everywhere. With the library compiled, this stops being a one-off story. The next Kilo that moves in the Baltic or creeps out into the North Atlantic will carry signatures that now light up faster, at longer ranges, and with fewer guesses. NATO didn't need torpedoes to win this fight. It walked away with a lasting fingerprint of a so-called quiet fleet under stress, lifted in real time through layered sensors and clean timing. That's how technology beats steel without a shot. The comprehensive take on Novorossiysk marks a victory for integration over brute force. In a crowded sea wired with sensors, silence isn't survival. It's a dataset waiting to be collected, indexed, and used the next time the periscope rises.